Good day everyone, welcome to Math with Teacher Justin. On today's topic, we're going to talk about solving systems of linear inequalities. Now on to our video. So here are the steps in solving systems of linear inequalities. So first step is for us to draw the graph of our equations. So in graphing our inequalities, please take note that when we encounter greater than or less than symbol, we plot our points using an open circle and we connect the points using a dotted line or a dashed line. So if we're given greater than or equal symbol and less than or equal symbol, we will plot our points using a closed circle and we will connect the points using a solid line. Step 2. Check which side of the graph will satisfy our inequality. We will assign testing points in order for us to identify the area or the region that will satisfy the inequality. Once we identify the area or the region where it will satisfy both equations, we will shade the side that satisfy that inequality. Take note that the intersection of the two regions is the set of all points that satisfy both inequalities. Thus, the region is the solution of the system of inequalities. Now, let's have some examples in solving systems of linear inequalities. Alright, okay, let's have an example. So, in our system, we are given x plus y is greater than 2 and x minus y is greater than negative 1. First step is for us to graph each of our equations. So, let's start first with x plus y is equal to 2. Let's graph this using the intercept method. Let's identify our x-intercept and our y-intercept. Let's solve for our x-intercept. So changing our variable y to 0 and solve for the value of x. So x is equal to 2. Our x-intercept is located at 2, 0. So in plotting our x-intercept, we will use an open circle because our inequality is greater than. Now let's solve for our y-intercept by replacing our x with 0. Let's solve for the value of y. Y is equal to 2. So our y-intercept for this graph will be located at 0, 2. So again, we will use an open circle. Now we will connect the 2 points using a dotted line or a dashed line. So that will be the graph of our first inequality. Now, let's proceed to our second inequality. So, let's graph x minus y is equal to negative 1. Let's use the intercept method in graphing our inequality. So, let's solve for our x-intercept by changing our variable y to 0. So, x will be equal to negative 1. So, our x-intercept is located at negative 1, 0. And again, we will use an open circle in plotting our x-intercept because our inequality symbol is greater than. Let's solve for our y-intercept. Let's change our variable x to 0 and we will have negative y is equal to negative 1. Let's divide both sides by negative 1. Our y-intercept will be located at 0, 1. So that will be our y-intercept for our second equation. Now let's connect the points using a dotted line or a dashed line. So this will be the graph of our first and second equation. Okay, next step is we will assign a testing point. So our testing point will be located at 0, 0. Again, you can use any coordinate, but for me, it's easier to simplify using zeros. Okay, so let's test our first inequality. Let's substitute 0, 0. We will have 0 is greater than 2. Did it satisfy our inequality? So it did not satisfy our inequality, so we will shade the upper portion of our first inequality. Now let's test our second inequality. So let's substitute our testing point 0, 0 and simplifying it, we will have 0 is greater than negative 1. Did it satisfy our inequality? Yes, it satisfies our inequality. Therefore, we will shade the region where 0, 0 is located. We will shade that area. Now, where is the intersection of all the shaded region? It is located here. Therefore, the purple shade will be our solution to our system of linear inequality. You can identify any point within this area and it will satisfy both of our inequality. So that will be our final answer. Alright, so let's have another example. So for example, we're given this system of linear inequality. So we have 4x minus 2y is greater than or equal to negative 4. And we have 2x minus y is less than or equal to 2. First step is for us to graph our inequality. So let's convert it to our equation. So let's graph it using the intercept method. Okay, so let's solve for the x-intercept and the y-intercept. So let's start first with our x-intercept. Let's change our y variable to 0. Let's solve for the value of x. We have 4x is equal to negative 4. So let's divide both sides by 4. Our x is equal to negative 1. So our x-intercept for our first inequality is located at negative 1, 0. So take note that we use a closed circle because our inequality symbol is greater than or equal. Now let's solve for our y-intercept. Let's replace our x variable to 0 and let's solve for the value of y. So negative 2y is equal to negative 4. Divide both sides by negative 2. Y is equal to 2. So our y-intercept is located at 0, 2. It is located here. Let's connect the 2 points using a solid line. So this will be the graph of our equation 4x minus 2y is equal to negative 4. Then let's proceed to our next graph. Let's graph 2x minus y is equal to 2. Okay, so let's use the intercept method. Let's get the x and the y-intercept. So let's start first with our x-intercept. Let's change our y variable to 0. We will have 2x is equal to 2. Let's solve for the value of x by dividing both sides by 2. X will be equal to 1. So our x-intercept will be located at 1, 0. Take note that we will also use a closed circle in plotting our points because our inequality symbol is less than or equal. Now let's proceed to our y-intercept. Let's change our x-coordinate to 0. So we will have negative y is equal to 2. Let's divide both sides by negative 1. Our y will be equal to negative 2. So our y-intercept will be located at 0, negative 2. Okay, now that we plotted our x and y-intercept, we can now connect the 2 points using a solid line. Now that we graphed our equations or our inequalities, we can now proceed to identifying our solution. In identifying our solution, we will use a testing point. Let's substitute 0, 0 to our first inequality. Simplifying it, we will have 0 is greater than or equal to negative 4. Ayan. Therefore, we will shade the lower part of our first inequality. Now, let's proceed to our second inequality. Let's substitute our testing point 0, 0. Simplifying it, we will have 0 is less than or equal to 2. Did it satisfy our inequality? Yes. So since our testing point satisfy our inequality, we will shade the upper portion of our graph. So let's identify the intersection of the two shaded region. It is located here. Therefore, the solution to this systems of linear inequality will be located in this shaded area. Alright, okay, let's have another example. So for example, we're given this system of linear inequality. For our first inequality, we have y is less than 3/4 of x minus 2. Okay, then for our second inequality, we are given y is greater than or equal to negative 1/2 x plus 2. So first step is for us to graph our first inequality. We will just change our inequality symbol to an equation symbol so that we can graph. We will use the slope-intercept method. So let's identify the slope and the y-intercept. So our slope is 3/4 and our y-intercept is located at negative 2. Okay, so let's plot first our y-intercept. It is located here. Now take note that we use an open circle because the symbol given is less than. Then let's use our slope to identify our next point. So we will have 3 units up and 4 units to the right. So our next coordinate will be located at 4, 1. And we will plot using an open circle. Then, since we have our 2 points already, we can now connect the 2 points with a broken line, dotted line, or dashed line. That will be the graph of our first inequality. Now, let's proceed to our second equation or second inequality. So, we will just change the inequality symbol to an equal symbol. Let's graph this using slope-intercept method. So, we will get the slope, which is negative 1/2, and our y-intercept, that is equal to 2. Okay, let's plot first our y-intercept. It is located here. And take note that when we plot for our second inequality, we use a closed circle because our inequality symbol is greater than or equal. Then, we use the slope in identifying our next point. So, since it is negative 1/2, we will move 1 unit down. So, our next point will be located at 2, 1. Now that we have 2 points in our graph, we can now connect the 2 points using a solid line. So now that we have our graph, let's now solve for our inequality. Now in solving our inequality, we will assign a testing point. So let's use 0, 0 as our testing point. Now let's test first our first inequality. Let's substitute 0, 0 to our first inequality. Testing it. Okay, and simplifying, we will end up with 0 is less than negative 2. So it did not satisfy our inequality. Therefore, we will shade the lower part of our graph. Okay, next, let's test our second inequality. So let's replace the variable x and y with 0. And simplifying it, we will end up with 0 is greater than or equal to 2. So it did not satisfy our second inequality. Therefore, we will shade the upper portion of our second graph. Let's identify the intersection of our shaded region. It is located here. So this will be our solution to our linear inequality. Okay, let's have our last example for today. So for example, we're given this system of linear inequality. For our first linear inequality, we are given y is less than or equal to negative 2/3 x plus 5. Our second inequality is 4x minus 3y is less than 12. Now, first step in solving systems of linear inequality is to graph each equation. So let's graph y is equal to negative 2/3 x plus 5. Now take note, we will just change the inequality symbol to an equal symbol. Since our equation is written in slope-intercept form, let's use the slope-intercept method in graphing our linear equation. So we get our slope, which is negative 2/3, and our y-intercept, which is equal to 5. And it is located at 0, 5. Now take note that we use a closed circle in plotting our y-intercept because the symbol that we use is less than or equal. So we're going to include the point as our solution. Then after that, we will use the slope to identify or to determine our next coordinate. We have negative 2, so 2 units down, and 3 units to the right. So this will be the location of your second point. Now that you have 2 points, we can now connect them using a solid line. That will be the graph of our first equation. Next is for us to graph our second linear inequality. Now, let's change the inequality symbol to an equal symbol so that we can graph it. Now, let's observe our equation. Since it is written in standard form, let's use the intercept method. Okay, so we will get the x-intercept and the y-intercept. So, let's solve for the x-intercept. Let's replace y with 0 and solve for the value of x. So, 4x is equal to 12. Divide both sides by 4. X is equal to 3. So our x-intercept is located at 3, 0. Now take note that we use an open circle because our second linear inequality contains a less than symbol. So we are not going to include this point as part of our solution. Okay. Next, let's solve for the y-intercept. So for the y-intercept, we will replace our x with 0 and solve for the value of y. Dividing both sides by negative 3, we will have y is equal to negative 4. So our y-intercept is located at 0, negative 4. So it is located here. Okay, take note, open circle when we plot our points. Now that we have our 2 points, let's connect our points using a dotted line or dashed line. Now we're done with graphing. Let's identify what area will be considered as our solution to this system of linear inequality. So we need to have a testing point. So let our origin be our testing point. So let's substitute it to our first inequality. Let's simplify. We will have 0 is less than or equal to 5. Did our testing point satisfy our linear inequality? Yes. Therefore, we will shade the lower part of our first inequality. Now, let's test our second inequality. 4x minus 3y is less than 12. Now, let's substitute the value of our testing point, 0, 0. Simplifying that, we will end up with 0 is less than 12. Did our testing point satisfy our second inequality? Yes. So since it satisfies our second inequality, we will shade the upper portion of our linear inequality where our testing point is located. Okay, so we will have that part. Then let's identify the intersection of our shaded region. And the intersection of the yellow and blue shade is located here. Therefore, the solution to our system will be located in this region, the purple region. Okay.
Now that you already know how to solve systems of linear inequalities, it is your turn to try it. Please click the link in our description box below in order for you to test your skills. That's it for today. Again, I'm Teacher Justin. Goodbye, God bless, and stay safe. See you on my next video. Peace!